Hello, so in the last tutorial what we did is we looked at how to left click to select individual units, how to box select, how to shift click units like that and then shift deselect, and we used a mixture of my script and some of UnitChat's methods, particularly for box selection and also for working out if we are dragging or not. So thanks UnitChat for that. In this tutorial what we're going to do is work out how to create basic formations, and this video has this code has two primary aims. One, that units never stack on top of each other, and two is that they can change their formation to fit strange locations like that sort of thing, and still not stack on top of each other. So that's the aim. The aim of this tutorial is not to have some sort of fancy or advanced formation pattern. That's going to come later. First things first, what we want to make sure is that consistently units do not stand on the same node or on the same vector 3, and that they can change their position if they're surrounded by unwalkable nodes or something like that. So if you're interested in getting a behavior like this, I will show you the script you need to understand. It's the unit manager script. And as you can see here, I have another finite state machine. I love finite state machines. Okay, I've added some comments here, a little bit, and then I suddenly got tired of it because this is just much easier for me to describe than to spend ages making comments about. But I encourage you to make your own comments based on what I tell you. Okay, so the finite state machine begins in this state, right-click target node. Then it goes down to this method here, right-click target node. And if the currently selected units count as greater than 0, so we have units selected, we don't want to do any of this if units aren't selected. So, let's just play the game. I can click as much as I like. I can do whatever I want, and nothing's going to happen because that code is not being executed. No one is selected. As soon as they are, now the currently selected units list is greater than 0. So where are you currently selected units? There we go. Right. Whereas now, currently selected units is 0. So that's what that's doing. That's how we work out whether or not units are selected or not, based on the number of people who are in the currently selected units list. Okay, so if that is greater than 0, if there are units who are selected, then we go down to the get mouse button if the right mouse button is clicked and we're not in build mode. So here's the next condition that has to be true. Currently selected units, I can left click, and all left click will do is deselect all the units, right? But if I right click and I'm not building, oh, so that's interesting. Okay, well now it won't work anyway. I also have this whole Boolean value variable there. I don't want to deselect them when I click on that. So let me show you how I fix this, because that's annoying, right? Imagine if you carefully select a bunch of units using shift and like, okay, I just want these particular units. Great, I've got to build something, and then they're all deselected. That's not a very good behavior, so let's quickly change that. Okay, to fix that problem, what I did was this. In the selection manager script, in this part of the code here in click or drag, when it's saying, did I hit something with the ray? So you have to hit something with the ray, but also you can't be hovering over any UI elements. So I'm going to show you what happens if you don't have this code in here. Right, so, oh sorry. So okay, so you selected all the units, and then you're hovering over a UI now, and that's what this does. It's a very useful little thing to have. You can, you have to put this, of course I've commented it out now, but you have to put this in there, this Unity Engine Event Systems. Then you come down here, and you can have this value which tells you whether or not your mouse is hovering over any UI element at all in your scene. So it's a very useful thing to have. Right. So right now this would be true. I'm hovering over a UI element, but because I've commented out that code, all the selection stuff still executes. So because I've left clicked and I've hit the ground, everything's deselected. So you have to make sure that this isn't executed when you're hovering over a UI element. So get rid of that. Now, the second thing we want to do is make sure that build mode is false. Because if build mode is true, and you've selected, whoops, let's play the game. can't really be called a game at the moment, I suppose. You've selected all of the units, and you've selected a tower, so they're still selected, right? Because it didn't trigger that code because we were hovering over a UI element when we left-clicked. But now I place a building, and everything's deselected again. So we have to make sure that right up until right at the end, you know, so build mode is true right until the very end. When it's instantiated, now it's false. So if we don't let any of this stuff happen while build mode is true, then when we place a building, they're still selected. And this still works with the basic logic of, this is just for debugging, by the way, guys. It's not a permanent feature of the game in any way. And so it still works. So it's so annoying. And I can place buildings and it won't deselect them. I can right-click while I've got a building and they're still selected, but even though I'm right-clicking like crazy, they're not going to move anywhere, which is really important. Otherwise you get some pretty bad bugs. Okay, so far so good, I think. Let's go back to the unit manager script. And we were here. Now, okay, so now if build mode is off and the right mouse button is down, then send out array, and if you hit something and that something is the ground, then I want you to store the, okay, now if you did the dynamic pathfinding videos, you'll know what this is, and if you did Sebastian Lague's videos, you'll know what this is as well. Okay, so temp target equals, so this vector 3 that we're storing up here in our variables there, that vector 3 is the same thing, or what the value we're going to put into that vector 3 is the node at that vector 3 location, but the vector 3 of that node. Okay, so that might be a little bit confusing to understand. But let's say I hit a location with the mouse, I hit a location on the ground which is like 12.87, 0 on Y, and then Z is like 50.92 or something like that, right? So then what this method will do is it will find the node which corresponds to that vector 3. But the location, the vector 3 location of that node is something a lot cleaner. It's something like 12, or would be something like 12.5, 0, 50.5, right? And so that's what we're doing. We're finding out, okay, which node corresponds to this vector 3 location. Okay, so we have that vector 3 location, we put that in there, and we find out the node that corresponds to that. And then from that node, what we get is we get the, because this returns a node, and then from that we get the world position of that node. So I said node a lot, I said vector 3 a lot, so I hope that made sense. But if you play around with it, it should become clearer to you. So always, if something I say doesn't make sense, use debug logs, use a whole bunch of things, experiment with the code, pull it apart, break it, mend it again, and it should make more sense to you. Okay, remove from targets and moving units. So we have to do this, basically. We have to make sure we've got a whole bunch of units are selected. Like this whole method wouldn't happen if units weren't selected. So we've got selected units. So before we move them to a new location, we have to make sure that we remove them from the moving units list. Now, if you've seen the dynamic path tutorials, you'll know what this is all about. But just for a quick recap, every time a unit is moving around the world, they are stored in this moving units list. And the reason why that has to exist is because of the dynamic building stuff. So let's say we've got this guy walking around and I place a tower on his path. He's got to be able to recalculate that path, and the only way I can know where he is or what's going on is I have a moving units list, and then when I place a building, I check that moving units list, and there's a list of game objects, if I haven't forgotten. Yeah, it's a list of game objects. And then I can find their unit script, and I can find their waypoints, their path list, which should be here somewhere. Yeah, there we go. So there's a vector 3 of their path, right? Array. So it's an array which is their path. So all their nodes basically are stored on there. that they're walking across, all their waypoints, and it checks that path to see if this is intersecting with any of those, and if it is, then they'll recalculate the path. Okay, but what we want to do is when we move units again, we have to make sure that if they are in that moving units list, we have to remove them from that. Otherwise you start getting a huge moving units list as you keep adding the same units to the list again and again, and then you'll get into trouble. Once we've done all of that, we move to calculate move area. We move to the state, and in this state, create walkable area is called, and we put this vector 3 in there, the same vector 3 that we got here. Right. Create walkable area. This code is a little bit, it's probably one of the longest methods I've ever written, but don't be put off. It's not as bad as you think if we talk about it step by step. So let's do that right now. To start with, I have a whole bunch of local variables. I think they're called local variables, like things that are used just in a method and they can't be used anywhere else. And they're all vector 3s, and then I've got these incrementers, right? So far I'm just stating the obvious. But when we go, what we do is we go into a for loop and we iterate 4 times, but that's arbitrary. You can do more than that or less than that. And the first thing that we do is we create this, we initialize this variable. So top left x, I'll show you which one that is so you have a visual. Oh, it's right here, okay. So top left, the top left one is here. Bottom left is there, top right is there, and bottom right is there. And what I do is I create this top left, and then I go, in the first iteration of the for loop, I go 1 to the right and 1 below. Then in the second iteration I go 3 to the right and 3 below. And then in the third iteration I go 5 to the right and 5 below. You can probably see what's happening. Every single time it's increased by 2, and that's how we get this sort of box shape. I guess it's an algorithm, it can be called that. Doesn't involve very complex maths. It goes 1, then 3, then 5, then 7, then it would be 9, and so on. And then it does the same down. This one also does that. So then it goes 1, 1, 3, 3, 5, 5, 7, 7, or however many times you want. And so that's what that does. And then every single time one of these is created, the vector 3 position is stored. And then also from that we can get the node that it corresponds to, and from that we can find out whether or not it's walkable or unwalkable. Also, every single time a unit moves to one of the targets, so let's say the first unit will move to here or something. What they've done is they've found that this, I'll just show you. Okay, so let's turn gizmos on. So where I was going to move him to, that first initial location, the starting position, was actually unwalkable. So what he does is he goes to the first available node based on the for loop. Unfortunately not based on his actual position to the node. I guess that would be more advanced if it was based on the closest node to him in his path, but it's based on how the for loop works. That's the first one that popped up. Okay, so that's what that's doing. Top left, you do that, so the starting position is going to be, this top left is going to be the starting position dot x minus the corner incrementer. So it's going to be here. Gizmos are not helping right now. So that's the starting position, and then the top left is going to be the x minus 1 and the z plus 1. So if you go x minus 1 and z plus 1, you get that. That's the top left. Bottom left is going to be x minus 1, z minus 1, you get there. X plus 1, z plus 1, you get there. And then z minus 1, x plus 1, you get there. And that's how we get our corners. Then what we do, so we get our corners that way, then every single time we've made a corner, we add it to this list of vectors. And this list of vectors are potential places the person could move to, right? But we don't know yet whether or not they're walkable or if other units are standing on there, so we have to do more stuff to work that out. Now, because this is the top left one, we have to use these edge maker methods, right? And this edge maker method is here, and it's called 4 times. It's for each one. For the top left, it's called twice, as it goes, this one here, top left, and it goes to the right once, and then this one goes down. So down in the z, this goes x across. And then the other time we call it is for the bottom right. And then this goes this way in the z, so it goes to the left. And this one goes up in the z. Again, it goes this way in the x, and then it goes up in z, like that. And the number of times it goes up is based on the side incrementer. The side incrementer starts at 1, so the first time it just goes 1. But the second time it's going to go 1 plus 2, right? So first time it goes 1, second time it goes 1 plus 2, 1 plus 2. Well, this actually was incremented, right? So it's going to be 3, but now it's going to be 3 plus 2. Now it's going to be 5 plus 2, like that. That's how that's working. And that's how you get that nice little square shape. So even though it looks like a crazy method, and it probably is a crazy method, and a more advanced programmer would probably look at this and go, yeah, you could have made that a lot simpler and more efficient. But it works. As I improve in my programming practice, I'll update these videos. If I learn some crazy algorithm, and I'll upload that. But, you know, I think this is kind of, it's useful. It does the job, and it's relatively easy to understand what's going on, I think. Anyway, it's my bias. Okay, so then this is the edge maker script. This is optional. This instantiating this game object. I just do that to get a visual understanding of whether or not it's working. So you can easily delete that or comment that out. And then also, of course, when we make the edges, those little red squares, we have to add those to the list of vectors as well. So this is what this has done. Now, in a previous iteration of this script, before I ran into a really irritating bug, what I would do is make, so for instance, in this case, you wouldn't have all of these vector 3's added. In fact, all you'd have is the number that you need to find an available node. So this would only be, this actually wouldn't have any at all, because the node that I clicked on was available. The next unit, however, you'd have to create this first iteration. And then you'd be good for another 1, 2, 3, 4, 5, 6, 7. Another 7 iterations would be fine. You wouldn't have to create any more. But then you get another unit, and you'd have to create this row of vectors to find another available node. And of course, if you had 2 buildings, and you had a really tight spot, then you'd have to create a lot of nodes, even if you had a few units, to find the next available node. I like that. I just had to get rid of it when I was debugging stuff. I ran into an issue, and let's talk about that right now, actually. In Sebastian Lague's original script, in his pathfinding script, units don't move directly to the target node. Let me show you what I mean. In fact, let me just uncomment the stuff that I changed in his script that allowed me to actually move to the target node. Without breaking anything, hopefully. Let's get rid of that. Let's see if this is broken or not. Okay, just slightly broken. Alright, so now you can see what's happening here is that he's not actually moving to that spot that I clicked, he's moving just before it. And if you have this happen, don't worry about the fact that he's walking, it's just I haven't set his walking to 0. It's not really that bad. We might as well just do that. Why not? So it doesn't look like I've actually broken the script in any way. So, he's moved there and not there. Now, what I showed you before, this method, with all of this stuff, when you add these exact positions to the list of vectors, and then we use that list of vectors to find the corresponding nodes to work out if they're unwalkable. If they're not unwalkable, then we move the unit to that node, and once the unit has moved to that node, then we store in a list of targets that units have actually moved to, and we check in future iterations whether or not it is also an occupied node as well. Hope that made sense. Now, the whole point of me going over that again is to emphasize that it's really important that units move exactly where I expect them to move, because if they don't, then the whole code breaks. So let me show you. That code is now disabled, and now if I make these houses, right click these guys and put them there, for instance, you're going to get some annoying stacking behavior. Or not. Okay, the worst one was the corners of buildings. Let's see if that stacks now. Okay, it's being irritating and working at the moment, but it shouldn't be. Ah, there we go. See that? It's hard to see, but they've stacked on top of each other there. And that was a little bit infuriating to me until I realized, they're not moving to where I'm telling them to move. No wonder it doesn't work. See, I'm saving you guys some suffering. Took a while to debug that. Anyway, so yeah, they have to move exactly where I tell them to move, otherwise it's going to break, basically. So let's go back. So what I did now, this is not a solution per se. What this really is a hack, because ideally, in the system that I'm building, they move to that target node by default. And I've used pathfinding solutions like Apex Path and A-Star Project Pro. I've got both of those, and they're both really good. And in both of those, you can move to the exact location where you click. I couldn't work out how to change Sebastian Lague's script so to do that. I made 2 posts on 2 separate forums, Stack Exchange and Unity forums, to try and find a solution. Someone recommended something, but it didn't work. It just led to some like index out of bounds error. And so as soon as I work out how to do that, I'll definitely change the code. I'll have to change his actual pathfinding script to allow for that. But in the meantime, this hack works. I'm just worried that this hack is going to create a bug further down the track. It's just a little bit disconcerting. I'd much rather have all the pathfinding handled by one method, especially for things like dynamic building. This makes me feel a little bit uneasy, and I think it's just a bug waiting to happen. But for now, at least it gets everything moving along, and I could make these videos and carry on with the game while someone else helps me work out how to change the pathfinding script fundamentally so units move to the final node. Okay, so what we do here is we get to the end of the path, and then we go to this state here. Move to target. There, and in move to target state, the move to target method is activated. Here, right? And so basically what that is that if the unit's position, this unit who has the script, if his position is not the same as the target where he's trying to get to, then move to the target. It's pretty straightforward, right? Then move towards that target and rotate towards that target as well. If you don't get them rotating towards the target, you get some strange behavior. So rotate towards the target and move towards the target. And then if the transform position is the same as the target, then go into idle and then go back to the move state and just, await my commands, basically. So that works as a nice little hack, but as I said, in the future I will hopefully be able to change Sebastian Lague's pathfinding script to allow for precise movement. Okay, so now what are we doing? Unit manager. So we've gone through all of this stuff. We've talked about the list of vectors and that sort of stuff that we're creating with this. You don't need those game objects, as I said before. Feel free to get rid of them. Now, once we've done all of that, so we've gone through this entire for loop, and we've created this sort of like these possible vector 3s that we could move to. Now what we do is you go to this state called create formation. And in create formation, find target for selected units is activated. And this is where we do the heavy lifting in regards to can the unit actually move there or not. I just noticed a little oversight. You see here in this method, find target for selected units. We're trying to find the closest available target in this method. And what I did here was I created a local list variable called selected units, and then I passed this value into that. Pass this value, I initialize it to have this value, which is just the currently selected units list found in the selection manager. We've talked about this one quite a lot at this stage. What I did is I made this variable, but then I went ahead and every single time I needed to access the currently selected units, instead of just putting selected units, I put, where's an example? I put this, which was silly, because the whole point of doing this is that this you can simplify the code. Instead of having this long line of stuff, you can simply have just selected units, because this is identical to that now, right? I think what I did was when I was trying to debug the script, I got rid of this, and I just thought that perhaps if I were to reference it directly, then it would circumvent the bug, but it was a totally not related issue. Okay, so anyway, so we first do this just for simplicity's sake. You don't need to do this, but if you don't, then every single time you want to access the list, you have to use this entire sentence, which is not good, this entire line. Then what we do is we loop through the currently selected units. So why that's important is that we're only doing this one unit at a time. So far what we've done hasn't been specific to any particular unit. We've selected all the units, so it's important that we had a list of selected units, otherwise none of this would be activated. But we've hit a a location and created our temp target. I'm going to not call that temp target anymore. I'm going to call it original target. That's a little bit more descriptive. Original mouse hit, perhaps? Original click position. Original right click position. Right, original right click position. Let's now find where we have to, right click position. Yep. Yep. And that's all. Okay, just because temp target made sense in a previous iteration of the code, but now it's a meaningless word name. Okay, so original right click position, as we talked about before, that happens here in this very first method that we run in this state. We go through, we hit the ground, and then the original right click position becomes the vector 3 of the node that we hit that corresponds to that right click position. And by right click position, just to be totally sure we're on the same page, means this. I right click and that is the right click position there. Okay, so, and that stays the same. This doesn't change at all. But then by the time we get to this code, so we've got that right click position, then we create that sort of cube, that square of possible locations, vector 3s, possible targets, and then we go down to this one here, create formation, and we're now in this method find target for selected units, and then we do the following. So new target, we've got a local variable new target that equals, okay, that's interestingly redundant. That equals that. I basically just ran the same code again unnecessarily, so I think that should work. Sorry guys, like I guess when you talk about something, you talk through something in the context of a video, you see things in a lot more detail and you realize that there are mistakes in the code or oversights, or things that made sense at one iteration of making the script but don't make sense anymore. So yeah, of course that works just fine. Okay, so sorry guys, yeah, you just want to have the new target equal to the original right click position, and then what we do is this. We go, if the node that new target corresponds to is not walkable, and new target, and the vector 3 of new target is one of the occupied nodes, so someone's standing on that vector 3 or they're moving towards it, then we have to find another vector 3 to move towards. However, if new target corresponds to a node that is walkable, and if it is not in the occupied nodes list, so no one is standing on it and no one is moving towards it, then we just sort of move towards that one without having to find any nearest nodes. So this will be activated if you have just one person. No need to find another node. Or if the node that the first node you click on is walkable. Need to find another node. I'll show you. Okay, so you got one guy and you move him towards that one, and there's no need to find another node. The other code isn't activated. But if I have this same one guy, let's put that building a bit closer for expediency's sake. The same one guy, and I move him to the corner of a building, then no need to find another node does not fire, and then suddenly we need to find another node because that one is unwalkable, right? And also in the context of multiple people moving towards a position, this is going to have to fire quite a few times, so 11 times. In total there's 12 units. One of them it didn't need to fire, so let's do that again. There's 12, there's 12 units. 3, 6. Ah, he's down there. Okay. I was like, oh no, I've come this far in the video and there's some terrible bug I wasn't aware of. Okay, no worries. Always ready to see some awful bug lurking around the corner. Right, in that case, quite literally. So here we go. Right, so then you'll have no need to find another node activated once, and then need to find another node activated 11 times, as every single one of these units cannot move to that original right-click position, and they have to find somewhere else to go. Right, so then they go into this method here, and the first thing that happens is that new node equals the what this method returns, and this method returns a new vector 3. So find closest available node, we pass into it the list of vectors, because this one wants a list. So let's find where that method is. Right, so we pass in that list of vectors, and remember the list of vectors is that thing that we added to here in this method. But every single time we made a new position, we added that position to that list of vectors, which was like the possible places units could move to. So we're down here, find closest available node, and we pass in that list of vectors, we loop through that list of vectors, and we have to ask if the position, if the node that this particular index of list of vectors corresponds to is walkable, and this list of vectors at this index is not occupied, then we return that position. And that's what new target now becomes for this unit. And then it goes down to here, and occupied nodes, you want to remove the target that the selected unit has already put into there, and then you want to add this new target there. Then you change the target variable on the unit script, this one here, to the new target. Then change the FSM on the unit script to find position, which will activate the pathfinding logic, and then change the FSM in this script to right-click target node so we can start the whole process again. And this one is a little bit more straightforward. You just don't have to do some of the stuff. All you have to do is remove the unit's target from occupied nodes just to make sure. Add the new target to occupied nodes, right? Because this is going to make sure that other units won't move to this position, because this new position is stored in occupied nodes. And then same as before, right? And that's pretty much it. We have come to the end of the code, except there's one more, clear list. Well, that's interesting. But I move to here in this method, and then I move to there at the end of the for loop. How can that be? Okay, so what was actually unnecessary was this. That doesn't make any sense being there. Instead, what you do is you just do that for each unit, and you keep looking through all the units and do that for all the units. Then you come to the end and you want to clear all the lists, and then once the lists are clear, and that's not even a method, it's just like list of vectors, all those possible locations that we can get to, clear that and make it null, and then go to right-click target node. Okay, right, that threw me for a little bit, as you can tell. Now it should work fine. Yeah, that's what we want. Now that's not complete, because ultimately, let's say if I move these guys here, and now that it's waiting here, but the list of vectors has been wiped. But if I'm moving other units around the world and there's AI and stuff like that, I still want to save their positions if they're just stationary. So that will come later when we start looking at AI and having all sorts of like people chopping down trees and mining rocks and going to this workstation or that station or this storage facility or whatever, going on like guard patrols, all that sort of stuff. We'll have to keep, if a character is stationary, we'll have to keep his position stored so no one else tries to move on top of him. But for now, this is fine. Okay, now it really is finished. That's the end of this tutorial. It's been quite long. So if you've watched this far, thanks a lot for watching. And if you have any questions, leave them below, or check out the Game Grind forum. It's good. There's good people there. There's no kind of arrogant people. I tell you, in my early years of of programming, like, well, it still is my early years of programming, but back in 2014 when I was just kind of trying to figure this stuff out, I posted a question on Stack Exchange that was deemed so stupid that I was almost banned. I was given like a severe warning. They say if you post like that again, you will be banned from Stack Exchange for, I think it was like 6 months or something like that. It was a question about debug log, and I made a debug log statement, and inside debug log I put a method, thinking that the debug log would tell me what the previous method was doing. But actually what happened is that debug log ran the method again. I didn't realize that it worked like that. I thought it would just tell me what the previous method did. And then people were being very arrogant and like, oh my god, I can't believe you thought that. I was like, dude, I'm new to programming, like, what do you expect? So you do run the risk, if you post on those forums, of getting smashed. If you're brand new to Unity and programming and stuff, I'd recommend something like Game Grind, because the people on there are really helpful, no question is too stupid and that sort of thing. Just one heads up, if you've got an issue with your code, post your code. Don't say like, I got a problem where the player won't move. And I was like, dude, you got to post your code, otherwise how am I going to help you? Okay, so anyway, that's the end of that tutorial. I got quite a few ideas about what I want to do next. But of course, leave any comments, and as long as what you want to do is in this sort of medieval fantasy genre, I'll be interested to try and help you guys out and find a way to do something like that. Okay, thanks again for watching.